This presentation includes 3 parts: the application demo, the tools we use, and the brief introduction of our application structure. Okay, let's get started. Firstly, we jump to our login page. We use the Google login by the Google Identity API, and the login application is deployed on the AWS EC2. So now I click the Google login. Then I can select my account. So when I successfully log in, our application will emit an event to Amazon SNS. It will call Amazon Lambda function, and it is used for recording the information in MongoDB by Event Bridge. And it will send a reminder email to my Google email account. So you can see I received a new email. I receive new email here, and I get the login information about the users. Next, we can get started for our first microservice. The first microservice is based on the Java Spring Boot, use controller and mapping to establish the API we use. It has full insert, delete, update, and search function. And it also has very good visualization effect and the functions of backpagination. First is the item train search. Item train search function receives at maximum 3 parameters to return the price trend within a specific time period or in a different region. For example, if I enter the type ID and the date, we can have the bar chart to represent the item price in different regions. And according to the item transaction search, it uses the type ID to return all the orders in the table. Like we use 194, then we got all the transactions. Okay, as for the insert, delete, update item, we all use the order ID as the primary key in the SQL database. As for time, we won't show how to do this, but we know the interface is like that. Okay, let's jump to the next microservice. It's called market map. The function of this service is to search the information of locations. We built a search engine using Flask and jQuery. When a user searches a location name, it calls a specific API to return location information by executing a SQL query, including its parent locations and the list of stations it has. For example, if I search guitar, you see the item ID, and it is solar system, and it has the stations in the list. So this is how the service works. So let's jump to our last services. It's called market orders. As we see, we can click the item in the list, and have the multiple drop-down list. So if I just click the join, and combat join, light scout joins, and any one of these, we see that it has lots of in it, and we have a pagination to each list. And if I want to sort them in prices, we can just click the column. It will just sort all the items in the sequence. When a user clicks on the market group, it calls the backend API to return the child group by the SQL query. The pagination and sorting are supported by APIs and our well-defined URL path, parameters, and query stream. There are special flags for the first page and the last page. All operations are done within the database system. Thus, it is very efficient and requires less resources for applications. However, MS2 has no access to the map database. We just have the station ID, and it is really vague when the user wants to use it. So we develop the composite services, which can be directed here. In here, we can search orders by a certain range. It calls both APIs from the microservice 1 and microservice 2 to connect the orders and locations. Link allows users to zoom in and out in the star map. You can click the URL to jump to the parent region, for example. So now let's see if it's Wellspar, and in the guitar region, click search and wait for the database to execute. So yeah, we get all the locations in the names of different transactions. Also, to achieve all of this, we use the S3 bucket to store the static resources and pages and encapsulate with the CloudFront. We also use a Flask server to support additional functions. We use the AWS API gateway in front of all of the microservices. So now I'm gonna show you the tools that we use to finish this application. First is the EC2 instances. Deployed our Spring and Flask application on it. The second one was the RDS. Yeah, the RDS. It is managing all the market information, and it could be updated by a thread that we made. Okay. Apart from that, we also use the SNS, the Lambda, the Event Bridge, and the CloudFront, the S3 bucket, Elastic Beanstalk. Also, we use a Docker for one of the services. And for the API gateway, this is the API gateway, and you can see how we arrange them. And we use Swagger Hub to make all the JSON file. So this is basically the first two parts of our presentation.
Okay, let's quickly go through the slides. Here's the background of our project. If Online is a really amazing game, you can see this is the map of New Eden, really complex and really interesting. This is what we have already finished. For the architecture, we have 3 microservices, each have one independent RDS. We use Elastic Beanstalk, we use Docker, we use EC2 instance. For microservice 1, it uses Google Identity Service and it triggers SNS to send email to user when they log in. It also triggers Lambda function to write data records to MongoDB. We have one composite microservice that directly calls microservice 2 and microservice 3. We have an API gateway in front of all the microservices. We have an S3 bucket for front end, and there's CloudFront in front of this stuff. We also have one independent Flask server to do more amazing stuff, as you have already seen in the demo. Here are ER diagrams. This example from our database, you can see how we define our schema and the data example. We use Swagger Hub for documents. You can check out the APIs, the response. We also use API gateway. We set a lot of parameters here. This is the example for S3 bucket and CloudFront. This is example for microservice 1, the front end, and for microservice 2. Microservice 2 supports sorting, support pagination. It has separate treatment for first and last pages. It has well-defined links. All of this stuff are supported by backend within database server. However, it has no access to station name, so it only has station ID. For microservice 3, a lot of fancy stuff. It can do insert, delete, and update. For composite microservice, it projects station ID to a real location, that is region, constellation, source system, and station, and you can jump to any locations. Also support by SQL. Here's the core function for middleware, Google Login, for Lambda function, the codes, the event bus, our MongoDB, subscriptions, and one example of the email reminder. For deployment, yes, this is one example of our EC2 instance, our Docker, our microservice 2 was on Docker Hub, the TMUX stuff, Elastic Beanstalk. This is example for one GitHub repo, MS2. Yeah, that's all. Thank you.